Hello guys, how are you? Um, Good to see you again, guys. Um, Before I start the second video, conditional probability, I'm sorry about the previous video. I was actually sharing my handwriting. I had cameras, but I think due to the technical issue, it didn't actually working. So you guys should have seen my face instead of my handwriting. But instead, I posted those handwriting in Blackboard and also sent out to your email. So please check that. I ordered another camera online, and it should be arriving in a couple of days. So from the third video or so, hopefully I can share my handwriting. Instead, for the this second video, I'm gonna write on my screen so that you can see. So, okay, let me share my screen again. Okay, today's lecture is about conditional probability. So far, you guys have learned that how to get the probability. Probability was what? Basically, the frequency of some particular interest over the total number of observation. Previously, our example was, okay, what is the probability of a female, or what is the probability of a male? Just if there are 450 females in some, pool out of like 1,000, let's say there are 450 female and there are 1,000 people in total. So probability of female is basically 450 over 1,000. So that is something we have learned. And using complementary rule, we can get probability of a male, which is 1 minus probability of female. Because summation of a probability was always equal 1. So if we know one probability, the other is basically a subtract from 1, right? So that was our idea. So this second chapter is about conditional probability. So conditional, as you can imagine from this term conditioner. So it's basically conditioning on something. What is the probability of this? For example, based on the last first lecture's example, okay, conditioning on someone living in South, conditioning on somebody is living in South region, what is the probability that somebody is female or male? So the statement is based on some, conditional statement. And maybe some of you guys have already learned this before, but this is very particularly important in economics because sometimes we are conditioning on something. What is the impact of something on something? So basically, this will be very useful later. So today we will learn conditional probability. Oh yeah, the reason why I'm looking at this is I have another screen that I'm sharing with you in another monitor. So today we will learn conditional probability. It is an extension from multivariable probabilities that we have learned previously, like where they are living and what is gender, like in two-sided tables. So that was a previous case. The purpose of this is, okay, whether a variable is related to another. So part one, we're gonna learn conditional probability and statistical independence. So independence means what? It's basically whether something is related to each other. For example, does the region of somebody is living related to their gender? For example, does gender is something to do with the place they are living, whether south or east or something like that? Those kinds of questions are independence, whether they are independence. But why statistical independence? Because we are actually testing that later. But but statistical independence is we're gonna cover very shortly. First, we're gonna learn how to compute conditional probability and how to check those statistical independence later. And second part, we're gonna learn Bayes' law. So that is a relationship among conditional and unconditional probability. And we can convert one to the other. And relevant textbooks are here. So part one, we will consider three examples. So is there discrimination in hiring process? Like, do you think, do data show men, there are, some discrimination in hiring process such that it's gonna be, it's gonna be like I should mute my chat. Okay, is there? Sorry, I'm sorry about that. So, for example, the man versus woman. I mean, if they apply for the same position, the probability of getting accepted might be different or not. So if there are some differences between that, that means, oh, there are some, discrimination. Or the second question is, does high tuition lead to high salary gain? Actually the answer can be done using some conditional probability. For example, if somebody is paying higher tuition, they are going to earn more money. That is kind of, economic question we can think of, And for also the third question, the sedan and truck market share of car makers. That is something we're gonna learn today. Okay. So let's look at the discrimination example. Of female applicants discriminated in hiring process. That is like a potential question, you can ask. So let's say M is like a male, F is a female, H is hired. So the homework you're gonna have for the second chapter will be something like that. So when I ask you do something like that, you might wanna transform those data into something like these tables. So I indicate M is as a female, a male, F as a female, H is hired. So H complement is not hired, it's 1 minus H, right? Something we have learned so far. So you might wanna just use some notation because sometimes the questions are long. You might wanna indicate that something equals something, So based on that, we want to convert this to probability, right? So how did we convert to probability? Let's first add all the number and figure out how many observations do we have. Okay, the summation of this is what? I think total number would be 1200 or something. So if we want to convert this to probability, so I will try to write this into, on the screen. So what we learned from the first chapter was, okay, put the M over here and F over here and H over here and H complement over here, something like that, right? So yeah. Okay, so the next step you want to do is fill this number. So let's pretend these are 1200. Is this right? Let me use my calculator really quick to double check. 288 plus 672 plus 36 plus 204. So yeah, 1200. So total number is 1200. And to get the this probability, again, that was joint probability. That was what? That was a probability that someone is male and it's N, right? That is actually joint probability or intersection, right? We learned yesterday, H, right? So that is something we are looking for. That is what? So how many observations did we have over here? That was 288 equal. So there are 288 people over here, 88. And how many total observations do we have? It's 1200. So if you calculate that, you're gonna get this probability. So let's calculate that using your calculator. 288 divided by 1200 is, okay, 0.24. So that is 24%. So put this as a 24. Yeah, 24% or something. And just fill out the remaining over here as well. So what is the probability of hire the female applicants? So, okay, let me give you, some couple of minutes. You might want to pause this video and try to answer this one, since I'm gonna leave you the answer right away, right now, okay? So, probability of hire the female applicant. So, somebody is hired and they are female, right? Then there are 36 people here. So answer is 36 divided by 1200, that is 3%. So you are looking for here, so probability of hired H intersection female, right? That was something you're looking for, which is 36 over 1200, right? 1200. So that is 3%. But probability of male intersection H is 24%, as we just discussed, right? So, I mean, based on this observation, can you say, there are some discrimination going on because this is higher than that? This is actually very important question. Also, one of the key question in this conditional probability. So please take a moment to answer this one. I will give you a couple more minutes. You might want to pause, otherwise I'm gonna leave you the answer. I mean, this would be really good practice when you actually pause the video and try to answer, because this kind of question might be, who knows, can be on the exam, So I know some people would say yes, and some people say no, because this number is higher than this, but would that be enough? The answer is no, because comparing between this and this is not fair, because, I mean, for some reason, the female applicants are, way lower. The number of applicants are way lower than male. So it's not fair. I mean, since there are 288, it's greater than 36. It doesn't mean that there exists any discrimination, right? So you need to compare apple to apple, right? So that means, okay, conditioning on they are male, what is the probability of higher? Or conditioning on female, what is the probability of higher? So that is more fair comparison. That is actually concept of the conditional probability, because there are more male applicants. This is a very important concept. Just keep that in mind. So if you guys have any question, again, just feel free to let me know. You guys know my email address, right? So always feel free to ask me if you guys have any question. So the fair comparison is the probability of hiring an applicant, conditioning on they are male. So in the homework question, homework problem, they're gonna ask if something is something, what is the probability of something like that. So after if statement is usually conditional probability. So if applicant was male, that is equivalent to, so excuse me, that is a conditioning on applicant was male, what is the probability of, hiring? So that is a conditional statement. If is usually conditioning statement. In the exam, I'm gonna mix if or conditioning on or suppose. So those three words are something many people use to indicate conditional probability. So conditional probability of hiring an applicant given. So given is another statement for conditional probability, because it's conditioning on a given that applicant is male. But I tend to use if, given, suppose, so anytime you see that, you can think, oh, that is, conditional probability. So you might be able to answer the homework too. Also, I wrote some hint over there, so you should be able to figure out. I mean, also, I didn't tell you earlier, I mean, there are reasons why I'm recording this video earlier, because, I mean, first chapter tend to be a little bit easier. So some of you just, you know, went through it so fast and maybe already submitted the homework. So I think, you know, I mean, since this material I was supposed to cover next week, but since we're not gonna have a final, instead we're gonna have a project. So I think, you know, covering material early, and then before you guys have any midterm or busy with other thing, you might want to focus on this this statistic course, and then of course later you can focus on other courses as well. So as we have time now, I think it's a good way of going forward quickly. So among this number, so summation of this number are number of males, right? So conditioning on, number of male, among them 288 are higher, right? So that is, okay, ignore this part, just ignore this part. Among, what is the summation of these two is, what, 960, right? Let's say 960, yeah. And so 960 would be your denominator, and numerator would be 288. So simply ignore the female data. So then the conditional probability is, okay, now 30% of male applicants are higher. And can you try to guess what would be the conditional probability of a female higher? So that is answer for this, question for this. Please take your time and, you know, bring up your calculator and try to answer this, okay? Okay, I'm gonna leave you the answer right now. So the answer is, so we can ignore male, right? And there are how many female? 36 out of 240, right? And the percentage is what? Actually, sorry. So 36 over 240. If you do the math, okay, 36 divided by 240 equal 15%. Okay, so conditional probabilities for female, given the, conditional probability of hired, given they are female, is only 15%. It was 30%. So maybe there are some evidences, but more, yeah, that is, you know, how we use conditional probability. So conditional probability of A given B. So that is how you write in terms of notation. Probability of A given, this is a given notation, conditioning on B. So conditioning on B occurred first. What is the probability of A? So that is actually conditional probability. So probability that A occurs when B has already occurred. So this occurred first, then A occurred second. So that is conditional probability. So like a previous case. So conditioning on, you know, they are female, what is the probability of higher? So these are notations. So probability of A given B is probability of A intersection B over probability of B, right? So that is something we already learned. This was what? This was joint probability. So numerator is joint probability. Denominator is what? Marginal probability, right? So that is equivalent to frequency of A intersection B, which was actually 36. And, you know, frequency of B, so frequency of B was a female. Summation of this was what? 240. So 240 goes as a denominator, and this one goes numerator. But this is one way, but most of the time you're gonna use this equation. Let me show you how you get this out of this equation. So previously we were able to recover this to probability, right? This was what? I think if I convert this again, it's gonna be something like, I think it was 24. I'm gonna just write over here, and it would be what? 36 out of 1200 was 3%, and 672 out of 1200, because we are filling up the joint probability. Pretend this is male, female, H and HC complement. 672 divided by 1200 is, oh, okay, 56%. And this is what? 204 divided by 1200 is a 17%, right? So this is just something you need to convert first. I mean, in homework 1, you guys practice this a lot. So using this formula, okay, what is the probability of A and B? Let's say, I mean, probability of F and H, that was 3%, right? So 3% goes to numerator. So that is actually probability of A and B, or probability of H and F, which was joint probability here. Yeah, just let me just fill this one for you. This one, M, H. I think just writing on this PDF file works pretty good. It's not bad, okay. But just bear with me, my handwriting is hard to write over here. And the summation of, so this is probability of B, or it's probability of a female. So in previous chapter, we learned that, okay, probability of a female is what? It's marginal probability. It's a summation of these two numbers, right? So that is actually 20%. And probability of male is what? 80%. And summation of this is what? 27. And summation of this is what? 73. Yeah. So probability of female is 20%. So 3 over 20%. That is exactly what you did. Probability of A intersection B, or probability of B. So 3 over 20, that is what? 15%. Just multiply 5 in numerator and denominator. It's going to be 15%. So which is exactly same as using frequencies. So you might think, okay, it doesn't matter which one to use, but that is absolutely true. But as we go more deeper and deeper, you might think this would be really easier, probably to be much easier. For example, let's say we have 360 million instead of 36. The number would be really huge, so that your calculation might take more time. But when you convert to probability, it's probably doesn't change. It doesn't affected by how many observations they have, you know. So later probability would be much easier, you know, trust me. So the next step, so that is something you guys want to do. And A is the event of interest, and this is a conditioning event. This is quite important. Probability of A given B is not equal probability of B of A. Actually, as a homework, I'm not sure whether I'm going to cover later, but try to see why this is not the same by using, for example, as a homework. I mean, you don't have to submit, but for your own practice, probability of hired conditioning on female was 15%. Can you try to find probability of female conditioning on hired? So, and can you see whether they are the same? You know, I mean, using this formula, please try to work with this. Yeah, I think I already, okay, hired, okay. I think I already gave something similar. Okay, this, is it typo? Okay, I mean, this is based on some conclusion, okay. So because, oh, sorry, I was confused, but this is a probability of higher the given female, and this is a probability of higher the given male. You know, what does that imply? Maybe discrimination against women, right? So because of this formula, if you solve for this one, we know this is this, right? How do you get this? Just from this equation, right? So A and B were switched. So it's going to be probability of A intersection B over probability of A over here. Yeah. Please try to do whether that makes sense. And now try to solve this for here, numerator. When you want to solve for numerator, how do you do? Multiply probability A both sides. Boom. This is how you get that. Okay. So probability of A intersection B is the probability of both occurring at the same time. That is intersection. Probability of A was marginal probability. This is probability of B given A. That is given A. What is the probability that B occurs? So that is another formula just from here, right? The reason why it's switched is, probability of A given B is what probability of A intersection B over probability of B, right? So if you solve for probability A or B, A intersection B, this is something you're gonna get. So please try to do this, whether that makes sense. Otherwise, let me know, okay? So in the Excel, so in the slide, course slide until the end of this semester, I'm gonna put some micro Excel function just in case you cannot access it. But I'm gonna demonstrate in our program in near future. Also, if you guys haven't downloaded our program in your computer, make sure you guys download it. Okay. So in the syllabus, there are website you can download R. It's free, so please download it. As you guys gonna use them for your final project, which accounts for 30% of your grade. Okay, we're not gonna have a final again. Instead, we're gonna have something like a final project. It'll be fun. Probability of, okay, that was a conditional probability and it's complementary. Probability of A not occurring when B occurs. So that is, using conditional probability. Summation of the probability are always equal 1. So if we know 1, so the other is what? Just 1 minus of the other. So that is how you do that. For example, previous case, you are able to find the probability of hire the given female, which was 15%. So without going further, you can get the probability of not hire the given female is 1 minus 0.15, 1.5, which is 0.85 or 85%. So using this complementary rule, okay, so MBA tuition. This is another example. Let's say MBA graduate from high tuition school have a higher chance of large salary gain. This is some kind of potential question you can discuss. Okay, let's say T is a tuition 50K or higher. That means complement of tuition is, of course, it's less than 50K. And salary gain is a 50K or larger. If we denote this as, for your homework, please try to denote like that so that the question might be much easier when you do that. So S is a salary gain. That means S complement is lower than 50K. So these are some distribution. I gave you this percentage instead, but if I gave you in the midterm, for example, you might want to convert this to probability. Now you can play around. You can find the conditional probabilities and everything, right? So we want to show that high tuition has nothing to do with high salary gain. So as I discussed previously, that is something to do with whether two events are independent or not. So is independent means they are nothing to do with. We are testing whether their events are independent or not, basically. So high tuition has nothing to do with the high salary gain. And what do you need to know? So please take some time on this. This is actually quite confusing potentially, but knowing this kind of notation from this wording is actually quite important, Everyone can do math, in statistics. So, but the difference in economic statistics is based on some statement, we want to get some mathematical notation. Math is a tool that we use to analyze data, but we are not only focusing on math, but we are interacting with the real life example. So again, pause this video, try to answer this, and I'm going to reveal the answer right now. So high tuition has nothing to do with that. Then what? What? Can you guess? Okay, I'm going to reveal the answer. We need to compare S given tuition. So given tuition, T or tuition TC complement. So whether you are paying more than certain number, how much was it? whether you are paying more than 50K or not, if those are the same, if we can compare these two, we know, okay, whether tuition affects salary. For example, if this percentage is higher than this, that means what? Okay, if you are paying higher tuition, you are earning more. But if they are the same, what? Oh, it doesn't matter. Tuition doesn't matter. Again, these are the selection. So tuition doesn't affect salary. So given tuition given you are paying higher tuition or given you are paying lower tuition, your salary probability of getting this salary is still the same. So that is ideal. Using this formula, and using this table previously, we are able to find probability of S given T is 25%. Okay, so without looking at the next slide, can you pause this video and try to find probability of S given TC? Now let's move that. Okay. So actually the answer, okay, before I reveal the answer, try to answer this by pausing this video. The answer for this one is 25%. That means what? It doesn't matter. So tuition doesn't matter. So that is your answer. That is how you can apply the data to answer some real life questions. So we say event A and B are statistically independent if this is true. That means what? If A and B are nothing to do with, means it's statistically independent. So whether you are conditioning on B or whether you are conditioning on B complement or whether you are not conditioning on anything, they are the same. That means they are statistically independent. So intuitively, based on previous example, so whether you are paying more than 50K as a tuition or paying less than that, it doesn't affect your salary you're earning. That means they are independent. They are nothing to do with. We say they are statistically independent. So remember this formula, it's very important, okay? I might ask this in midterm, So okay, statistically independent, interpretation is A has no effect on B. So basically they have nothing to do with the tuition doesn't affect your salary. So between two groups, B and B complement, the outcome A is the same. So whether you're conditioning on B or B complement, your salary would be the same, something like that. So information on A doesn't help you to predict B. So that is interpretation. That is how the economic statistic kicks in. So maybe in previous statistic, you have learned if this is true, statistically independent, but in economics, if they are independent, this is how you interpret, okay? So conditioning on something doesn't affect anything. That means they are nothing to do with each other. So these are some of the examples. Vaccine independence of getting disease. So whether you get vaccination or not, does that affect disease? Or GDP growth of this independent? Today's stock return independent of tomorrow's? Those are some economic examples. So how to check independence? There are at least 3 ways. Actually, there are 3 ways you can think of. So if those are the same, then they are independent. You can change A and B and play around, still make the same. For example, previously, probability of getting higher salary is equal probability of getting higher salary given, they are paying higher tuition. Or similarly, equal probability of getting higher wage gain is equal to probability, the conditioning on the tuition you are paying less than 50K. So these are some but if they are not equal, you cannot say they are independent. This one does not mean independence. You need to switch this one. So probability of A equal probability of A given B. So this doesn't mean independence. Be careful with the notation, okay? Second one is using this one. So previous slide, couple slides ago, we found that this one is from, so probability of B given A was what? Probability of A intersection B over probability of A, right? So multiply probability of A, you got multiplication rule. And if they are independent, that means what? This probability of B given A is what? So using previous question, so probability of A equal probability of A given B, that means probability of B equal what? Probability of B given A. So based on that, this is what? Probability of B, right? If they are independent, right? So if they are independent, this one equal probability of B using this one, right? Using this first one, okay? So substitute back, that means probability of A intersection B equal what? Probability of A times probability of B. That means they are independent, right? So this is actually mostly used in statistics. So I mean, all the equation give you the same result, but sometimes this one is super easy to check. For example, we were able to find the marginal probability. For example, what is the marginal probability of this S? Is adding this two number is what, 25%, right? So probability of S equal 25%, and probability of T equal what? Summation of this is what, 45%. And you can check, okay, is the probability of T intersection S is multiplication of this? Let's find it out. So, oh, actually, is it 40? Yeah, okay. So 0.45 times 0.25 equal, oh, 11.25 percentage. So that means, oh, okay, multiplying the marginal probability of S times probability equal this one. Oh, okay, that means they are independent by our second definition, right? So that is how you use the, independence. Okay, the second equations. Okay, so that was a multiplication rule. This is very, very important, okay? Okay, these were the independence, and let's consider automaker share. For example, these are some distributions. The interpretation of probability of H is, oh, okay, Honda's overall market share, because that is a probability of H, right? So what is the probability of somebody is buying Honda? So that is what summation of this is 40%. Of course, these are coming from some random numbers. So probability of Chevy is 25%, and probability of Ford is 35%. So these are all marginal probability. So probability of Honda given sedan. So ignoring truck, what is the probability of sedan? Probability of Honda given sedan. So that is what? How did you get that? It's 32.5 over summation of this number, right? Summation of this is what? 39. Is it 39? Yeah, 39 plus this one is what? 60%. So this is 60%. So, oops, yeah. Okay, so we can do this one as well. Okay, so we can tell conditioning on sedan or conditioning on truck, which market share is bigger, then it can tell you what is Honda's strength. So previously, the conditional probability of this one was what? 32.5 over, let me use my calculator. 32.5 divided by summation of this one was okay, 60%. That means about 54%. And you can get the same calculator probability of H given T, which is 7.5 divided by summation of this number, which should be 40%. That would be your market share. So probability of H is this, and this is 54%, and using this, you can get this one. So that is ideal for the conditional probability, okay? So we can check whether they are the same. So are they are same? No, right? So probability of S intersection H, here S intersection H is 32.5, but this is not equal to 24%. That means they are not independent. That is how you conclude that. So can you say Ford and truck are independent? Ford and truck over here. So is, in other words, it's a 14% is equal probability of truck, which is marginal probability, times the probability of Ford. You can try and let me know what you found, okay? How to convert this to this, okay. Okay, let's convert this to this. I mean, how to convert this to this. I'm gonna do like 2 more examples. So let's say, suppose that a manufacturing firm receive parts from 2 different suppliers. So, supplier 1, A1, and supplier 2, A2. A1 supplies 60%, A2 supplies the other 40%, right? So because the summation is, excuse me, summation should be always 100, right? So if in exam, if I give you only this one, then that implies A2 is 40% without getting more information, right? So A1 is better in quality than A2. So A1, 2% of A1 are defective and 7% of A2 are defective. So given this information, okay, so if I say D as a defective, just indicate for D. So can you derive some information? So like we learned in first chapter, like the range of some joint probability we learn. Okay, 2% of A1 parts are defective and 7% are defective. How can you express this information? This is actually very important for your exam and your understanding. So please take as much as your time and pause this video and try to answer this. So how can you express this information? Okay, I'm gonna reveal the answer, okay? So how many of you do you think answer is C? Okay, how many of you do you think answer is A? Okay, so I mean the answer is one of the other, right? So can you tell me which one? Okay, so 2% of A1 parts are defective, right? So they are 2% of something is defective. So probability of a defective given the part is A1, which is here is 2%. So 7% of A2 part are defective. So probability of defective is 7%, but what? Given A2. So it should be this part A, right? So probability of defective given A1 is 2%, probability of defective given A2 is 7%. We know this is a 60%, and we would like to calculate that. Please try this video and spend like 10 minutes to try to find this one. If you can find earlier than that, that is also great, but absolutely try this one, okay? Okay, so we would like to calculate this one. To do so, we want to recover this one first. So given this information, probability of A1 equal what? 60%. So probability of A1 is 60%. So just write over here, 60. And probability of A2 is what? 40%. 40. So probability of defective given A1. So that is what? Probability of defective given A1, right? A1 equal what? 2%, right? Yep. So based on the previous equation, what is the probability of A given B equal what? Probability of A intersection B over probability of B, right? So that is probability of defective intersection A1. Sorry, I'm slow. And over probability of, previous case was B was given, so it should be A1. This is something you got to be familiar yourself for the exam. So something we are looking for is actually this one, because that is joint probability, right? So probability of D and A1, which is over here, joint probability would be here. So we know this is what? 2%, right? This is 2%. What is the probability of A1? It's a 60%. Oh, so what is this? Multiply this too. So bring this one to the other side, or multiply probability of A both sides so that it's gonna be eliminated. So, and then probability of A goes here. So probability of A times probability, conditional probability of D given A1 equal this one. So 0.6 times 0.02 equal basically 0.012. So that is how you do that. Similarly, you can do this one, like a probability of D given A2 is 7%, right? So that is a 7%, and then and what do we need to do? So, and that is what probability of D intersection A2 over probability of A2. Since we know probability of A2, that goes denominator. And we know probability of D given A2 is 7%. So probability of D intersection, or probability of D and A2, which is joint probability that we're gonna fill this one, it is something. Okay, so we were able to fill this one and this one. And we got this one as a 60%. We got this as a 40%. If we know this, and if we know this, summation of this is this, then of course you can fill this one, right? Similarly here, you know this one, and you know this one, summation of these two equal this. So 1.2% plus something equals 60%. What is something? Of course you can do the math, right? That is how you get the answer. I mean, based on the class, I mean, this slide, this is another example. I mean, probably this is another good method, but I prefer this method. That's why I taught you, but you can take a look at this as well. But let's say this is one example, like let's pretend that there are 1,000 observations. So if there are 1,000 observations, for example, 600 parts are made by A1, because 60% of total parts are made by A1. That is a probability of A1 was 60%. So 0.6 times 100, 1,000 is 600. Similarly, it's 400. The reason why we do this is, I mean, if we use a frequency instead of probability, sometimes some people think it's easier. So that's why we are covering this, but both methods are exactly fine. As I discussed before, if you use a frequency, it's fine, but why did we make 1,000? You can choose your number, but as this is something 1,000 or 10,000, because we're not gonna have any decimal points, so it's gonna make the calculation much easier. So you can make it 10 or, or actually 100, but depending on the location, maybe 1,000 would be better or 10,000 would be better, but you can do this one. So then how do we get this one? So probability of D complement of A1, you can get using the previous method I taught you, so that is 588 over 600, but in previous case, what I taught you was it's 1.2%. And this was 60%, so 1.2% plus something equals 60%, of course it's 58.8. So that is, yeah, that is actually how you get this 588, and this is a conditional probability, right? Conditional probability of this one given this is, based on our previous example, that is 58.8%, and the summation of this is 60%. So 58.8% divided by 60%, that is about 98%. So same thing, whether you use a frequency or not, it doesn't matter. And probability of this equal 1 minus of this, and we know this is 2%, so that is another way of getting 98% using complementary rule. Math is math. Even if you use other method, it doesn't matter. You'd get the same final answer. Okay, so you can find the probability of D, right? So probability of D is, so it would be 1.2%, it would be 2.8%. So summation of this would be 4%. Please try to do the math and let me know if you guys have any question, but make sure you guys try. Otherwise, if you never try, you're not gonna learn, you know? So please try. You can use, pretend you have 1,000 parts, or you can use the method I use. For example, this was 1.2 and 2.8. Again, how did we get 2.8? We know conditional probability of D given A2 is 7%. But 7% is something which is here, something here over 40%. So the something equal was 7% times 40%, that is 2.8%. Because 7% is 0.07, 40% is 0.4. If you multiply, it's gonna be 0.028, which is 2.8%, okay? Now, either way, it would be fine. So using frequency table, you can get this result. For example, summation of this is 40% and 40, and total number is, we make the assumption is 1,000. So 40 over 1,000 is also marginal probability. So this is total number of 40 divided by total number, that is probability of D. Try to do with the 10,000, you would get exactly the same answer. If you have, by all means, please try to do with 100 or 10,000. Believe me, you're gonna get the same answer. So this this 12, which was actually 1.2% in our example, is coming from 2% times 0.6. So this is how it's working, but I'm gonna actually skip this part because this is how we use a Bayes law, but definitely this is just math. It's nothing more than just what we just did. But take a look at this, okay? You can also try to look at this one as well. If we pick a defective part at random, what is the probability that it's made by A1? So after if is conditional statement, as I told you before, this is actually in the homework. So if I say if something, let's say is A happen, what is the probability of B? That is actually probability of B given A, right? So that is a conditional probability, right? Because if this one happened first, so it goes to here, and what is the probability of B? So we are looking for probability of B given A, so that is if statement, okay? So we are looking for what is the probability of A1 given defective, so please try to do that. Probability of A1 given defective is probability of A1 intersection D over probability of D. So to the math, you do get this one, okay? So if you saw it so quickly, go back to your video, try to pause, and whether you get the same answer, okay? So these are some of the examples. Mathematically, these are equivalent, but for now, I think it's, you don't have to learn that because it's a Bayes law rule, but something we already know intuitively. So these are some derivation and examples, but we can get the exactly same answer. So you don't have to memorize it as long as we understand the intuition. So for the reason I'm skipping this, you can answer this one also easily using Bayes law, but you can try to look out go with some other method, and you will find that one is easy. So the last example we're gonna do is Down syndrome screening. But since this is something repeatant, so something we already did many times, I will leave this as your homework. So you don't have to submit that, but take a look at this slide carefully. It's basically the same question and all the answers are here. But please try to go over this example by all means, okay? But if you have any question confusing, feel free to email me. I'm always available to help you. If needed, we can set up a Zoom meeting, etc. So I will post the homework. You can try to do it later, okay? So again, this presentation was supposed to be for next week, but since we did it so quickly for the first lecture, so I posted so that you guys can take a look at. But I think finishing early would be better because you're gonna have more time for our midterm, so that I can give you some extra lecture like office hours or review section like that. Also, we can go over our program for the final project. So let's try to wrapping up really quickly so that we can move. If you guys confused, please go back to the lecture, try to listen again. If you guys still have a question, always reach out to me, okay? Okay, then have a great day with you guys, and talk to you again soon, okay? Bye.